Mars has always been Earth's enigmatic neighbor, a world so close, yet so utterly alien. It's a place where the sun sets in blue hues, where mountains tower taller than Everest, and where winds whisper across deserts of rust-colored dust. But beneath its haunting beauty lies a planet shrouded in mysteries that have puzzled scientists, inspired dreamers, and defied explanation for centuries. What if I told you that despite all our rovers, orbiters, and telescopes, Mars still holds secrets that leave even the brightest minds scratching their heads? From bizarre geological formations that shouldn't exist to strange lights flickering in the darkness, this red world is hiding puzzles that challenge everything we think we know. Imagine standing on the surface of Mars, gazing up at a sky that's both familiar and eerily different. You'd see dust devils taller than skyscrapers carving paths across the plains. You'd hear the silence, a silence so profound it's almost deafening, and then you might notice something off, a crater that looks like it was carved by something unnatural. A pattern in the rocks that defies geology, a fleeting glimmer that vanishes before you can blink. These aren't just quirks of the landscape, they're clues to a planet that refuses to give up its secrets easily. For every answer we uncover, Mars seems to throw two more questions our way, leaving us wondering, what else is hiding in plain sight? That's exactly what we're diving into today, 25 of the most baffling, spine-tingling mysteries Mars has to offer. Some of these enigmas might make you question whether we're alone in the universe. Others could rewrite the history of our solar system, and a few might just keep you up at night. But one thing's for certain, by the time we're done, you'll never look at that rusty dot in the night sky the same way again. So buckle up, because we're about to take a journey into the unknown, where every discovery raises new questions and where the truth might be stranger than anything we've dared to imagine. The first mystery takes us back to 1976, when the Viking 1 orbiter captured an image that would ignite imaginations worldwide, a haunting formation in the Cydonia region that eerily resembled a human face staring up from the Martian surface. Stretching nearly 2 miles across with shadowed eyes, a pronounced nose, and even what appeared to be lips, the so-called face on Mars sparked a firestorm of speculation. Was this a trick of light and angle, or evidence of a lost civilization? The idea that an ancient culture might have left behind a monument carved to gaze eternally into the cosmos felt like something straight out of science fiction. Yet for years, the debate raged, fueled by blurred images and the tantalizing possibility that we weren't alone. Then came the twist. Decades later, advanced missions like Mars Global Surveyor and Mars Reconnaissance Orbiter returned with crystal-clear photos of the same region. The high-resolution images revealed something far less dramatic, a weathered mesa, its features smoothed by eons of wind and erosion. The face was little more than a rocky hill, its human-like appearance shattered by the cold light of better technology. But here's where it gets interesting. Even with the scientific explanation, the allure of the face on Mars never truly faded. Some researchers point to unusual symmetry in the formation, arguing that natural erosion alone can't account for its striking geometry. Others wonder, if not a face, could it still be something else, a landmark, a beacon? The controversy lingers, a reminder of how easily our minds seek patterns, even in the barren landscapes of another world. What makes this mystery endure isn't just the question of what we saw, but why we wanted to see it so badly. The face on Mars taps into something deeper, our hunger for connection in the vast silence of space. Whether a quirk of geology or a relic of something grander, it challenges us to ask, how much of what we discover is truly out there, and how much do we bring with us when we look up at the stars? The Cydonia region isn't just home to that infamous face. It's a sprawling gallery of geological oddities that have fueled speculation for decades. Picture a landscape dotted with pyramid-like formations, their angles suspiciously precise, clustered together like the ruins of some ancient city. One of these, known as the D&M Pyramid, named after researchers Vincent Di Pietro and Gregory Molnar, boasts 5 distinct sides, with measurements that some claim align too perfectly with sacred geometry to be random. Then there are the fortress structures, their walls appearing unnaturally straight against the chaotic Martian terrain. It's no wonder this area has become ground zero for those who believe Mars once harbored intelligent life. But here's where science pushes back. Geologists argue that wind, erosion, and the planet's violent volcanic past could easily sculpt these features over millions of years. The so-called pyramids, they're likely mesas, their sharp edges carved by relentless dust storms. The fortress, just another plateau, its straight lines a trick of perspective and lighting. Yet even with these explanations, Cydonia clings to its mysteries. Why? Because humans are pattern-seeking creatures. We're wired to find meaning in chaos, to see faces in clouds or castles in cliff faces. Mars, with its stark, alien beauty, amplifies that instinct tenfold. What keeps Cydonia fascinating isn't just the rocks themselves, but the stories we project onto them. This region forces us to confront a tantalizing question. If life did exist on Mars, how would we even recognize its remnants after eons of dust and decay? Whether you see an ancient metropolis or just a wind-scoured wasteland, Cydonia reminds us that exploration is as much about imagination as it is about evidence. And in that tension between what we know and what we want to believe lies the enduring magic of Mars. Ever since the first grainy images of pyramid-like structures appeared in the Martian landscape, scientists and enthusiasts alike have been locked in a debate that feels ripped from the pages of an interplanetary detective novel. These formations, scattered across regions like Cydonia and Elysium, rise from the rusty soil with angles so crisp they seem almost deliberate. Some appear in clusters, their bases aligned as if plotted by some unseen architect, while others stand solitary, their peaks casting long shadows across the barren plain. On Earth, such precise geometry would instantly conjure images of the Great Pyramids of Giza, monuments built with purpose by human hands. So what does it mean when we find their doppelgangers on another world? Geologists have a compelling answer: pareidolia, the same trick of the mind that lets us see animals in clouds or faces in mountain cliffs. Mars is a planet sculpted by extremes, blistering winds that sandblast rock for eons, ancient lava flows that cooled into jagged plateaus, and meteor impacts that fracture the crust into unnatural-looking shapes. The so-called pyramids, they argue, are likely butts or mesas, their sharp edges the result of relentless erosion stripping away softer layers over millions of years. High-resolution scans from modern orbiters support this, revealing surfaces pockmarked by the same chaotic weathering seen across Mars. Case closed, not quite. Here's where the plot thickens. Certain formations, like the trio dubbed the Elysium Pyramids, exhibit near-perfect symmetry, with sides angled at close to 30 degrees, a slope eerily reminiscent of Earth's ancient monuments. Measurements taken from rover data even suggest some align with celestial events, much like how the pyramids of Giza point to Orion's belt. Could these similarities truly be cosmic coincidence? Or is there a vanishingly small chance that some structures on Mars are more than wind and whimsy? The truth may lie somewhere in between. While mainstream science dismisses artificial origins, a few researchers float a provocative middle ground. Natural doesn't always mean random. Earth has its own accidental pyramids, like the Matterhorn's razor-edge peaks or the hexagonal basalt columns of Giant's Causeway, geological marvels that look engineered but were forged by pure physics. Mars, with its lower gravity and thinner atmosphere, might amplify such processes, creating even sharper, more improbable shapes. What makes this mystery endure isn't just the question of what built these formations, but what they reveal about us. Every time we project our own history onto Martian rocks, we're grappling with something profound. If life did arise elsewhere, would its footprints resemble ours at all? Or are we, in our hunger for familiarity, mistaking the universe's artistry for a mirror? Whether you see ancient ruins or wind-carved wonders, the Martian pyramids challenge us to separate what's possible from what's plausible, and to wonder, just maybe, if the line between them is thinner than we think. When the Opportunity rover rolled across Mars Meridiani Planum in 2004, it stumbled upon a scene that looked straight out of a cosmic art gallery, millions of tiny, spherical pebbles scattered like beads across the rust-colored soil. Scientists quickly dubbed them blueberries, not for their color, they're actually gray, but for their uncanny resemblance to the fruit's shape and size. These weren't ordinary rocks, ranging from mere millimeters to the size of BB pellets. Their near-perfect roundness defied the jagged, wind-battered geology typical of Mars. And when Opportunity's instruments analyzed their composition, the plot thickened. These blueberries were packed with hematite, an iron-rich mineral that usually forms in the presence of liquid water. Here's why that sent shockwaves through the scientific community. On Earth, hematite spherules like these often form in two ways, either slowly, as mineral-rich water percolates through porous rock, depositing layers over millennia, or rapidly, in volcanic eruptions where molten rock splashes into droplets that solidify mid-air. But Mars doesn't play by Earth's rules. The sheer abundance of these blueberries, some patches stretching for miles, suggests water once flowed through the planet's subsurface like a vast, invisible sponge, chemically altering the rock grain by grain. Yet modern Mars is a freeze-dried desert, its atmosphere too thin to support liquid water for long. So how did these tiny time capsules form in such mind-boggling numbers, and what does their presence tell us about the planet's soggy past? The leading theory is a process called concretion, a geological slow dance where water laden with dissolved iron seeped through Martian bedrock, gradually accumulating around microscopic nuclei like layers of an onion. Over eons, the softer surrounding rock eroded away, leaving the hardened spheres behind like marbles strewn across a sandbox, but some details still don't add up. Certain blueberries are hollow, their interiors crumbled like ancient eggshells, a feature rarely seen in Earth's hematite concretions. Others cluster in dense fields, while nearby areas sit eerily empty, as if some unseen force curated their distribution. Then there's the wild card. Could these spherules be volcanic? A minority of researchers argue that asteroid impacts or lava fountains might have sprayed molten droplets across the landscape, though this doesn't fully explain their iron-rich chemistry. What's clear is that these unassuming little orbs are more than geological quirks. They're tiny witnesses to a time when Mars wasn't the barren world we see today. Each one holds clues to the planet's lost oceans, its vanished rivers, and the tantalizing possibility that where there was water, there might have been life. The blueberries force us to confront a humbling truth. Sometimes the smallest things carry the weight of the biggest mysteries. To hold one in your hand would be to touch a relic of a wetter, wilder Mars, a world that may have once pulsed with the very ingredient that sparked life on our own planet. And that's the real magic of these minuscule marvels. They're not just rocks, they're echoes. Methane should not exist on Mars, at least not in any significant quantity. This simple gas, made of just one carbon atom and 4 hydrogen atoms, is a notorious troublemaker in planetary science. On Earth, most methane comes from living things, cows digesting grass, microbes munching on decaying plants, even the fizzing swamps of prehistoric wetlands. So when orbiters and rovers started sniffing out whiffs of methane in the thin Martian air, the discovery sent shockwaves through the scientific community. Here's the puzzle. This methane doesn't behave like it should. It appears in sudden, unpredictable spikes, sometimes vanishing within weeks, as if the planet itself is playing a cosmic game of hide and seek. The first detection came in 2003, when the European Space Agency's Mars Express orbiter caught traces of methane floating over the Hellas Basin, one of Mars' largest impact craters. Then, in 2013, NASA Curiosity rover puttering around Gale crater confirmed it. The gas was real and it was fluctuating wildly. Levels would soar to 10 times the background average, then crash back down before scientists could pinpoint the source. Even stranger, the spikes seemed seasonal, peaking during Martian summers, a rhythm that, on Earth, would hint at biological activity tied to temperature and sunlight. But before we start picturing subterranean Martian microbes exhaling methane, let's consider the other possibilities. Geology can produce methane too, through processes like serpentinization, a reaction between water, carbon dioxide, and certain minerals deep underground. Mars has plenty of volcanoes, though most are thought to be long extinct. Could residual heat be cooking methane out of ancient lava tubes? Maybe. Then there's the mystery of methane's rapid disappearance. Sunlight should break it apart over centuries, yet the gas vanishes far faster than chemistry alone can explain. Some researchers speculate that salts in the Martian soil might be acting like a sponge, absorbing and releasing methane in cycles we don't yet understand. The stakes couldn't be higher. If the methane is biological, it would be the strongest clue yet that life, even in microscopic form, exists beyond Earth. But if it's geological, it still points to something extraordinary. Active processes deep within Mars, perhaps even reservoirs of liquid water where chemistry is still churning away. Every new detection adds another layer to the riddle. In 2019, Curiosities instruments picked the largest spike yet, 21 parts per billion, enough to make headlines worldwide. Yet days later, the European Trace Gas Orbiter, designed specifically to hunt methane, flew overhead and found nothing. How could one instrument smell a feast while another tasted only thin air? This isn't just a scientific discrepancy, it's a detective story with two competing sets of clues. Some argue the methane is breaking apart before it reaches the upper atmosphere where orbiters scan. Others wonder if Curiosity, sitting on the surface, is detecting local leaks from tiny cracks in the Martian crust, like whispers of gas escaping a sealed tomb. The truth might lie in the planet's complexity. Mars isn't a static monument, it's a world with weather, seasons, and possibly even underground plumbing we've barely begun to map. What makes the methane mystery so compelling isn't just the question of its origin, but what it reveals about our own biases. We hunt for methane because on Earth it's a beacon of life. But what if Martian biology, if it exists, operates by rules we haven't imagined? Or what if the universe crafts methane in ways we've yet to discover? For now, the red planet keeps its secrets, releasing tantalizing hints only to snatch them back, leaving us to wonder. Are we smelling the breath of hidden organisms or just the slow sigh of a geologically restless world? Either answer would rewrite the story of Mars and our place in the cosmos. High on the sun-baked slopes of Mars, something strange happens every summer. Dark, finger-like streaks emerge from the shadows, creeping downhill like ghostly rivers before fading away as temperatures drop. These fleeting marks, some stretching longer than a football field, were first spotted in 2011 by NASA Mars Reconnaissance Orbiter. Scientists dubbed them recurring slope lineae, a clinical name for a phenomenon that sparked one of the most heated debates in planetary science. Is liquid water still trickling on Mars today, or are we witnessing an elaborate illusion crafted by sliding sand? The case for water began with tantalizing clues. These streaks appear exclusively on warm, steep slopes, mostly inside craters and valleys where sunlight lingers. They darken and lengthen during the Martian summer, then vanish when winter's chill sets in, returning the following year like clockwork. Early spectral analysis suggested the streaks contained hydrated salts, minerals like perchlorates that can lower water's freezing point, allowing briny liquid to flow even in Mars' sub-zero temperatures. If true, this would mean the red planet isn't entirely dead. Somewhere beneath its barren surface, water might still be seeping, pooling, or even trickling into view. But nothing on Mars is ever that simple. In 2017, high-resolution scans revealed a puzzling detail. The streaks only appeared on slopes steep enough for dry grains of sand to naturally avalanche. Experiments with simulated Martian soil showed that cascading dust could create similar dark trails without a single drop of water. Then came the clincher. New spectral data found no definitive evidence of liquid in the streaks themselves. The hydrated salts, they were everywhere on Mars, not just near the Lineae. Suddenly, the water theory looked shakier than ever, yet the mystery only deepened. Some streaks exhibit branching patterns eerily reminiscent of terrestrial streams, their paths weaving around obstacles like liquid seeking the path of least resistance. Others darken from the top down, a behavior dry sand shouldn't mimic. And then there's the speed. Certain streaks advance several meters per day, far quicker than most landslides observed on Mars. Could this be a hybrid phenomenon, part dry flow, part damp trickle, where trace amounts of brine lubricate sliding grains without leaving a detectable watery signature? The implications are staggering. If even a trickle of liquid water exists on modern Mars, it would revolutionize our understanding of the planet's potential to harbor life. Microbes on Earth thrive in similar briny films in deserts like the Atacama or Antarctica's dry valleys. But if the streaks are purely dry, Mars becomes a world where geology mimics biology so precisely it taunts us with false hope. Perhaps the most fascinating twist is how this debate mirrors our own cognitive biases. We want those streaks to be water, they look like water, yet Mars has spent eons reminding us it plays by its own rules. Whether the truth leans toward damp chemistry or dazzlingly dry deception, these inscrutable streaks are a masterclass in how much we still have to learn, and how patiently the universe makes us work for every answer. One day in 2014, the Opportunity rover's cameras captured something bizarre, a rock that hadn't been there before. Just 12 days earlier, the same patch of Martian soil near Endeavour crater had been empty. Then, like magic, a pale, smooth stone roughly the size of a donut appeared on the dusty terrain. Scientists nicknamed it Pinnacle Island, and its sudden arrival sparked a mystery that still hasn't been fully solved. How does a rock just materialize on a planet with no known geological activity or living things to move it? The leading theory is as simple as it is chaotic wind. Mars may have a thin atmosphere, but its gusts can still pack a punch, especially during dust storms that rage across the planet for months. One particularly violent gust might have dislodged Pinnacle Island from a nearby slope, sending it tumbling directly into Opportunity's field of view. Supporting this idea, the rover's panoramic images revealed a shallow depression just uphill from the rock, as if something had been scooped out of the soil. But here's where things get strange. Pinnacle Island wasn't just any rock. When Opportunity's spectrometer analyzed its composition, it found unusually high levels of manganese and sulfur, elements that on Earth often concentrate in water-rich environments. This raised eyebrows. Could this unassuming little stone be a fragment of some ancient mineral-rich layer exposed by erosion? Then came the curveball. Some researchers proposed an even wilder possibility, that Opportunity itself had kicked up the rock. The rover's wheels, grinding across the rugged terrain, might have flipped it into position during a routine drive. It wouldn't be the first time. Previous rovers have accidentally dislodged stones while navigating slopes, but Pinnacle Island's chemistry complicates this idea. If the rock came from beneath the surface, why does its composition differ so sharply from the surrounding soil? Unless Mars' underground layers are far more varied than we thought, this theory leaves gaps. Perhaps the most intriguing angle is the rock's uncanny resemblance to terrestrial concretions, small, rounded stones formed when minerals precipitate around a core, often in watery conditions. On Earth, these form in riverbeds or lake bottoms, their layers accumulating over centuries. If Pinnacle Island shares this origin, it could be another breadcrumb in the trail pointing to Mars' wet past. But without knowing exactly where it came from, its story remains frustratingly incomplete. The true lesson of Pinnacle Island isn't just about a single wandering rock, it's about how much we still don't see on Mars. The planet is constantly shifting, reshaped by winds we rarely witness and processes we've yet to understand. A rock appearing overnight might seem trivial, but it's a reminder that even in our robotic exploration, Mars retains the power to surprise. Every time we think we've got it figured out, the red planet tosses another mystery in our path like a cosmic magician refusing to reveal its tricks. And that's what makes this journey so exhilarating, because who knows what might appear or disappear tomorrow. In August 2012, NASA Curiosity rover sent back an image that set the internet ablaze. A grainy black and white snapshot of the Martian horizon where, nestled among the rocks, a shadowy figure appeared to be crouching. With what looked like outstretched arms and a discernible head, the silhouette bore an unsettling resemblance to a human form, instantly earning nicknames like the Mars Woman or the Martian Mona Lisa. Tabloids ran wild with theories. Was this proof of ancient civilizations, a statue, or worse, something still alive watching our robotic explorer from the rusty hills? Science, however, tells a far more fascinating story, one about the quirks of human perception. This phenomenon, known as pareidolia, is our brain's hardwired habit of finding familiar shapes in random patterns. It's why we see dragons in clouds, faces in electrical outlets, or even the Virgin Mary in toast. On Mars, where wind and erosion sculpt rocks into endless variations, pareidolia runs rampant. The Mars Woman is likely just a curiously shaped boulder, its humanoid appearance amplified by low-resolution imaging, dramatic lighting, and our own imagination filling in the gaps. But here's where it gets interesting. High-resolution follow-up images revealed the truth. The figure was nothing more than a jagged rock outcrop no taller than a footstool, its arms and head formed by overlapping shadows at just the right angle. Yet even with cold, hard evidence, the myth persisted. Why? Because pareidolia isn't just a trick, it's a survival instinct. Our ancestors who spotted predators hidden in foliage lived to pass on their genes. That legacy makes us hypersensitive to patterns that might signal danger or opportunity, even in the sterile sands of Mars. What makes this case unique is how it exposes the tension between exploration and expectation. We land rovers on Mars hoping to uncover the unknown, yet we're haunted by the urge to see the familiar. Every smudge, shadow, or oddly angled stone becomes a Rorschach test for our deepest curiosities and fears. The Mars Woman isn't evidence of life, but she is evidence of something equally profound, our relentless drive to connect, even with a world that offers no answers. So the next time you spot a face in the cliffs or a figure in the fog, remember, you're not just seeing rocks, you're witnessing the echo of a mind evolved to seek meaning in the void. And on Mars, where every mystery outlasts its explanation, that's a reminder we might need more than we realize. Deep in the wasteland of Mars' Phlegra Montes region, a solitary structure juts from the rust-colored soil, a stark, rectangular slab towering over the surrounding terrain like a sentinel from another age. Captured in 2011 by NASA, a high-rise camera, this so-called Martian monolith measures roughly 5 meters tall and appears eerily geometric, its sharp angles and flat surfaces contrasting violently with the chaotic landscape. At first glance, it looks like something carved, placed, or at the very least arranged, an impression that sparked endless comparisons to the enigmatic monoliths of science fiction. But is this a trick of geology, or could it be something far more extraordinary? Earth has its own monoliths, natural formations like the towering basalt columns of Devil's Tower or the precariously balanced boulders of Monument Valley. Even our moon boasts similar oddities, like the much-debated tower spotted in lunar images, which some claim resembles an artificial spire. What unites these features is a phenomenon called jointing, where cooling lava or sedimentary rock fractures into geometric patterns. On Mars, where wind erosion lacks the softening touch of water or vegetation, such formations might appear even more unnaturally crisp. The phlegra slab could simply be a remnant of an ancient lava flow, its surrounding rock worn away over eons until only this defiant shard remained. Yet there's a tantalizing counterpoint. The monolith's near-perfect 90-degree angles and uniform thickness are rare even in jointed formations. Some researchers note its resemblance to megaliths on Earth, deliberately placed stones like those at Stonehenge or Easter Island's Moe. Could this be a marker left by some long-vanished civilization, or perhaps a fragment of wreckage from a cataclysmic event? The math gives pause. The odds of a naturally occurring rock fracturing into such precise geometry are vanishingly small, though not impossible. Here's where the plot thickens. Zooming in on high-rise, high-resolution images reveals a crucial detail. The monolith casts a shadow that doesn't quite match its presumed shape. What looks like a solid block from one angle might actually be a crumbling outcrop, its flat surfaces roughened by time. And then there's location. Phlegra Montes is a tectonic maze of ridges and valleys, a place where landslides and seismic shifts could easily sculpt deceptive silhouettes. The truth might lie in scale. From orbit, even a jumble of boulders can appear unnaturally orderly when viewed from miles above. What makes this monolith unforgettable isn't just the question of its origin, but what it reveals about our hunger for meaning. Humans have always projected significance onto the unexplained, from attributing lightning to gods to interpreting celestial events as omens. The monolith, whether a trick of light or a genuine anomaly, forces us to confront an uncomfortable truth. The universe is under no obligation to make sense to us. Mars, with its silent, windswept plains, doesn't care if we see monuments or mirages. But that's precisely why we keep looking, because buried in that tension between what we see and what we long to see lies the beating heart of exploration. So is the monolith natural or not? Science leans heavily toward geology, but the real answer might be simpler: it doesn't matter. What matters is that a single rock, half a universe away, can still make us stop, stare, and wonder if we're truly alone. And in that moment of uncertainty, Mars becomes more than a planet. It becomes a mirror. Mars has a habit of swallowing our machines whole. Of the dozens of probes, landers, and rovers we've sent to its surface, some vanish without a trace. No final signals, no crash sites, just silence where there should have been triumph. Two of the most haunting disappearances belong to the British-built Beagle 2 and NAS, a Mars polar lander. Missions that didn't just fail, but vanished into the red planet's void under circumstances so bizarre they still fuel whispers of sabotage, bad luck, or something darker. Take Beagle 2, named after the ship that carried Charles Darwin into scientific legend. In December 2003, it detached from its mothership, the Mars Express orbiter, and began its descent toward Isides Planitia, a basin scientists hoped might hold clues to ancient life. Everything seemed perfect until the moment it was supposed to phone home. Nothing came, no telemetry, no beeps, just static. For years, the probe's fate was one of Mars' most stubborn mysteries. Then, in 2015, NASA Mars Reconnaissance Orbiter spotted it intact, even eerily pristine. Its solar panels partially deployed like a butterfly that never quite took flight. The official explanation: a faulty airbag or parachute likely caused a hard landing, knocking out its antenna, but conspiracy theorists pounced. Why did it land so close to its target if it was out of control? And why did NASA take 12 years to find it? Some even suggested the craft's instruments, designed to detect life, might have been too successfully silenced before it could broadcast a discovery too disruptive to acknowledge. Then there's the Mars Polar Lander, which vanished without even that much closure. Launched in January 1999, it was supposed to touch down near the planet's southern ice cap, studying climate history. On December 3rd, as it entered the atmosphere, Mission Control lost contact forever. The leading theory blames a software glitch that mistakenly shut off the engines 60 meters above the surface, sending the lander crashing down. But anomalies abound. Amateur radio operators claimed they detected a faint signal days later, as if the lander had miraculously survived. Others pointed to strange marks in later orbital images, scars that looked like the lander had skidded across the ice before vanishing. The wildest theory that it was shot down, not by malfunction but by something else. What makes these cases so chilling isn't just the failures but the pattern. Mars has an uncanny knack for snatching our machines at the worst possible moment. The Russians lost multiple probes during the Soviet era, like Mars 3 in 1971, which transmitted for 20 seconds before going dark forever. NASA Mars Observer vanished in 1993 just before orbital insertion. The list goes on, a graveyard of silent metal strewn across the red dust. Science points to a brutal truth: space is hard. Mars' thin atmosphere makes landings a nightmare. Its dust storms scramble signals. Its temperature swings fry electronics. But when probes vanish without clear causes, it's human nature to wonder, are we alone in this silence? Or is something watching, waiting, ensuring we never hear the answers we seek? The lost probes teach us something profound. In our quest to uncover Mars' secrets, we've created myths as vast as the planet itself. Every unexplained failure becomes a Rorschach test. Do you see bad engineering or something more? Either way, Mars keeps its secrets, leaving us to stare into the static and wonder what else might be listening. Among the rippled cliffs of Mars Mount Sharp, a photograph from the Curiosity rover made global headlines in May 2022. Not for some groundbreaking discovery, but for what looked like a perfectly rectangular doorway carved into the rock face. Roughly the height of a person, with a shadowy interior that seemed to promise passage to some hidden underworld, this Martian door instantly fired imaginations. Conspiracy forums erupted with theories. Was this an entrance to an alien base, a portal to another dimension, or perhaps proof that someone or something had once lived beneath the Martian surface? Geologists were quick to temper the excitement. What the public saw as an artificial doorway, they explained, was likely a simple fracture in the rock, a phenomenon so common on Earth we hardly notice it. On our planet, such crevices form through shear stress, where opposing forces stretch or compress rock until it snaps. Given Mars' violent tectonic past and relentless temperature swings which can make rocks expand and contract by inches daily, it's no surprise the planet is littered with cracks. What made this one stand out was its uncanny geometry. The door appeared almost perfectly rectangular, with a flat lintel and vertical sides, a shape that screamed deliberate construction to pattern-seeking human eyes. But here's where science gets fascinating. That very illusion of precision, it's often just a trick of perspective. The doorway was only about 30 centimeters tall in reality, far smaller than it appeared in photos. And far from being a solitary anomaly, the surrounding rock face was pockmarked with similar fractures, most tilted at odd angles. Only this one happened to align perpendicular to the rover's camera, creating the illusion of intentional design. Even the shadowy interior turned out to be nothing more than a shallow recess, barely deep enough to hide a loaf of bread. Yet the wildest twist isn't the rock itself, it's how stubbornly the myth persisted. Long after scientists debunked the door, alternative theories flourished. Some pointed to similar doors spotted elsewhere on Mars, like the Stargate formation in Arabia Terra, a massive circular pit resembling a sci-fi portal. Others noted that on Earth, ancient cultures often built doorways to sacred spaces in cliff faces. Think Petra's rose-red monuments or the tombs of Egypt's Valley of the Kings. Could Mars geology simply mimic what human hands have carved elsewhere? Perhaps the real lesson here lies in our own perception. The doorway illusion taps into something primal, the allure of thresholds, the promise of passage. For centuries, humans have projected meaning onto caves, arches, and cracks in the earth, seeing gateways to the divine or the unknown. Mars, with its silent, sun-baked cliffs, offers the ultimate blank canvas for these instincts. Every shadow becomes a tunnel, every rock a ruin. So next time you see that famous door photo, remember, you're not just looking at a crack in a rock. You're witnessing the collision of two worlds, one of cold, indifferent geology and another of human longing, where every unexplored corner whispers the possibility of wonder. And in that tension, Mars reminds us that the most alien landscape we'll ever explore might just be the space between what's there and what we desperately hope to find. From a distance, they look like rows of shadowy trees stretching across the Martian dunes, a sprawling forest where no forest should exist. Captured by NASA, a Mars Reconnaissance Orbiter in 2008, these eerie formations in the planet's northern polar regions baffled the public, with their branching, almost organic patterns fanning out like blackened shrubs against the rusty sand. But zoom in closer, and the truth is far stranger than fiction. These aren't plants at all. They're avalanches of dust, rivers of shadow cascading down dunes, frozen in mid-fall by the snap of a camera. The science behind this illusion is as beautiful as it is deceptive. During Martian spring, sunlight warms the polar ice caps, causing slabs of carbon dioxide frost to sublimate, transforming directly from solid to gas without becoming liquid first. As this gas builds beneath the surface, pressure mounts until it explosively bursts through the overlying layers, sending dark basaltic sand sliding down the slopes like ink spilled across parchment. The trunks and branches we perceive are actually trails left by these tumbling grains, their paths carved by wind and gravity into shapes that mimic Earth's flora. The darker the sand, the sharper the contrast against the bright frost, creating silhouettes so crisp they trick the eye into seeing life where there's only physics at play. What makes this phenomenon so mesmerizing isn't just the visual trickery, it's the scale. Some of these trees stretch for hundreds of meters, their shadows lengthening as the sun dips low on the horizon. Time-lapse images reveal their fleeting nature. What looks like a permanent forest is really a snapshot of perpetual motion, with new branches forming as old ones vanish under shifting sands. It's a reminder that Mars, for all its stillness, is a world in constant, if imperceptibly slow, flux. The Mars trees also expose a deeper truth about how we explore alien worlds. Our brains are wired to interpret unfamiliar landscapes through the lens of what we know. Just as early astronomers mapped canals onto Mars deserts, we project forests onto its avalanches. This isn't just a flaw, it's a survival mechanism. Recognizing patterns, even false ones, helps us navigate complexity. But Mars, with its indifferent geology, doesn't care about our metaphors. Those trees are a lesson in humility, a cosmic Rorschach test reminding us that the universe owes us no familiarity. Yet there's a tantalizing footnote. In 2021, researchers studying similar features in Antarctica's McMurdo Dry Valleys, one of Earth's closest Mars analogues, found something unexpected. Certain dust avalanches there left patterns eerily resembling microbial colonies when viewed from above. Could the Martian trees, for all their geological origins, still hint at a subtler truth? That even in illusions, nature sometimes leaves clues to deeper mysteries. Whether answering that question or raising new ones, these shadowy cascades prove one thing: on Mars, even the tricks of the light have stories to tell. In July 2015, NASA Curiosity rover transmitted a photo that sent the internet into a frenzy. A grainy image of a rocky outcrop where, nestled among the Martian boulders, a jagged shadow seemed to lurk with outstretched limbs, poised like some alien crustacean ready to strike. Dubbed the Mars crab monster, this eerie silhouette quickly became legend, with conspiracy theorists insisting it was proof of hidden life crawling through the red planet's crevices. The truth, as always on Mars, is far more ordinary. and infinitely more fascinating than fiction. What the human eye interpreted as claws and a segmented body was in reality just another rock. Not even a particularly large one, roughly the size of a dinner plate. But when sunlight hit its weathered edges at just the right angle, the resulting shadow contorted into a shape our brains couldn't help but recognize. This phenomenon, known as pareidolia, is the same quirk that makes us see faces in electrical outlets or animals in cloud formations. Our ancestors relied on this instant pattern recognition to spot predators in dense foliage or identify food sources. On Mars, where every landscape feels alien, this hardwired instinct runs wild, turning ordinary geology into a gallery of imagined creatures and artifacts. What sets the crab monster apart from other Martian illusions is the sheer intensity of the reaction it provoked. Unlike the vague face on Mars, which required squinting to see, this shadow was undeniably crab-like to anyone glancing at the photo. Claws appeared articulated, a central body seemed armored in segments. Even the posture suggested movement, as if the creature had frozen mid-scuttle. Scientists at NASA, a jet propulsion laboratory, joked they'd found the Martian equivalent of a coconut crab, but the public response veered into genuine belief. Some claimed NASA was covering up evidence of indigenous life. Others speculated the crab was a fossilized remnant of a lost ecosystem. Digging deeper reveals why this specific illusion resonated. Crabs and crustaceans in general occupy a unique place in human psychology. Their exoskeletons and jointed limbs make them look both familiar and alien, tapping into what biologists call the uncanny valley of the animal kingdom. When we project that form onto a Martian shadow, we're not just seeing a random shape, we're confronting the eerie possibility that life elsewhere might follow evolutionary paths parallel to Earth. The crab shape also benefits from simple geometry. Angular rocks casting sharp shadows naturally create the pinching lines we associate with claws. High-resolution follow-up images dismantled the myth, showing the rock from multiple angles where it resembled nothing more than a nondescript stone. Yet the crab monster endures as a case study in how even skeptics can fall prey to pareidolia when confronted with the unknown. Astronomers call this the Mars effect. The planet's stark lighting, wind-sculpted geology, and our own cultural baggage conspire to create visions where none exist. From Viking's Happy Face crater to the more recent Mars Bigfoot shadow, the red planet has become a Rorschach test for our cosmic anxieties and hopes. Perhaps the real lesson here isn't about rocks or shadows, but about humility. Every time we project earthly life onto Martian landscapes, we risk missing the truly alien wonders right in front of us. The next time you see a crab or a face in Mars photos, remember, you're not just looking at a planet, you're seeing the reflection of a mind evolved to find meaning, even in the echoing silence of a world that offers none. And that, in its own way, is more extraordinary than any monster. On the wind-scoured plains of Mars Cydonia region, the same area that birthed the infamous face, a lesser-known but equally haunting formation lurks. Nicknamed the Martian Sphinx, this cluster of rocks bears an uncanny resemblance to the Great Monument of Giza, complete with what appears to be a regal headdress and stoic, weather-beaten features. Discovered in archived images from the Viking missions, the Sphinx presents another masterclass in how Mars twists geology into ghostly imitations of Earth's most iconic landmarks. The secret behind this illusion lies in the planet's relentless winds. Unlike Earth, where water smooths and rounds rock over time, Martian erosion is a one-man show performed by fine, abrasive dust carried in hurricane-speed gusts. These particles act like sandpaper, sculpting soft rock layers faster than harder ones, a process called differential erosion. Over millennia, this creates stepped formations with flat planes and sharp angles that look carved, even though no hands touch them. The Sphinx's headdress, likely a resistant caprock protecting softer stone beneath, creating a staggered profile. Its face, a boulder balanced atop the main structure at just the right angle to mimic a profile when shadows stretch westward. But the fascination with this formation isn't just about wind physics, it's about cultural echoes. The original Sphinx sits at the heart of human civilization, a symbol of riddles and ancient knowledge. To find its shadow on Mars taps into something primal, the idea that meaning transcends worlds. Psychologists call this anthropomorphic projection, our tendency to imprint human significance onto natural shapes. Yet Mars takes this instinct further. Without forests or oceans to soften its landscapes, every jagged outcrop becomes a potential artifact, every shadow a hidden message. Scientists have tools to debunk these illusions. High-rise images reveal the Sphinx as a jumble of fractured bedrock, its features dissolving into chaotic rubble when viewed from alternate angles. Spectral analysis confirms it's made of basalt identical to the surrounding plains, with no unusual mineral signatures hinting at artificial origins. But here's the twist. Some astrobiologists argue these very processes might create real landmarks for future explorers. On a world without roads or signs, wind-carved formations could serve as natural navigation aids, a cosmic inside joke where geology does the work of civilization. The Martian Sphinx endures not because it's a mystery, but because it's a mirror. Every time we see a monument in the rocks, we're confronting the limits of our own perception and the boundless creativity of natural forces. Mars doesn't need sculptors. With enough time and wind, it can turn a mountain into a myth all by itself. Stretching beneath the Martian surface like the veins of some colossal, long-dead beast, a network of mysterious tunnels winds through the darkness, some so vast they could swallow entire city blocks. These shadowy passageways, spotted from orbit as faint, snaking depressions or gaping skylights in the planet's crust, have fueled scientific speculation and wild theories alike. Are they the remnants of ancient lava rivers hollowed out by volcanic fury, collapsed tunnels from a vanished underground world, or perhaps, most tantalizing of all natural shelters waiting to house future astronauts when humans finally set foot on the red planet? The most widely accepted explanation points to lava tubes tunnels formed when molten rock erupts and flows across the surface. As the outer layer cools and solidifies, the still liquid interior keeps moving, eventually draining away to leave behind a hollow conduit. Earth has its own lava tubes, like Hawaii's Kazumura Cave, which stretches over 65 kilometers. But Mars, with its lower gravity and lack of tectonic activity, could host tubes of unimaginable scale. Some estimates suggest Martian lava tubes might span hundreds of kilometers, with ceilings lofty enough to fit the Empire State Building lying on its side. Orbital images reveal telltale clues, sinuous ridges that trace the tube's collapsed roofs or sudden pits, called skylights where the ground has caved in, offering a glimpse into the abyss below. But what makes these tunnels so compelling isn't just their origin, it's their potential. Mars' surface is a death trap. Cosmic radiation bombards the landscape unchecked by a thick atmosphere. Dust storms rage for months, blotting out the sun. Temperature swings can plunge from 20 degrees Celsius at noon to -73 after dark. Underground, though, the rules change. Lava tubes offer natural shielding from radiation and violent weather. Their interiors might maintain stable temperatures, trapped in the eternal chill of the Martian subsurface. Some scientists even speculate these tunnels could harbor traces of ancient water ice, precious fuel for future colonies. The European Space Agency has dubbed them nature's ready-made habitats, and NASA, a Moon-to-Mars mission planners, are already studying them as potential outpost sites. Yet the mysteries go deeper. In 2020, researchers analyzing data from NASA, a Mars reconnaissance orbiter, identified a series of bizarre, repeating patterns near the planet's equator, long, meandering grooves flanked by raised ridges like tire tracks pressed into dust. These sinuous ridges bear a striking resemblance to subsurface lava tube remnants on Earth, where collapsed tunnels filled with later lava flows, leaving behind casts of their own skeletons. If confirmed, these ridges could hint at an even grander subterranean network, one that once carried rivers of fire beneath the Martian plains. Then there's the enigma of Hebrus Valles, a region scarred by what look like chains of collapsed tunnels, their ceilings caved in like a row of dominoes. Some stretches remain intact, their arched passageways eerily reminiscent of man-made subway tubes. Could these be the bones of an ancient lava river system, or signs of something more exotic, like underground aquifers that froze and collapsed when Mars lost its water? The answer might lie in the dust. Recent studies suggest some tubes could still be stable, their walls reinforced by layers of hardened magma or permafrost acting as cosmic cement. The wildest theories push even further. A handful of researchers point to odd, light-reflective properties in certain tunnels, wondering if they're coated in unusual minerals or even ice deposits protected from sublimation. Others note that some tubes cluster suspiciously near regions rich in methane plumes, sparking whispers of microbial refuges hidden from the surface's harshness. Of course, the sobering truth is that most of these tunnels are likely just geological relics, frozen in time for billions of years. But in science, as in exploration, sometimes the most practical discoveries begin with the wildest dreams. For now, these tunnels remain tantalizing shadows, their secrets locked behind layers of rock and time. But one day, perhaps sooner than we think, a rover might lower itself into one of those skylights, its headlamps slicing through the darkness to reveal what Mars has been hiding all along. And when that day comes, we might find more than just shelter. We might uncover the red planet's untold stories written in the echoes of its subterranean halls. Among the countless rocks photographed by NASA Opportunity rover in 2004, one stood out, a fractured slab nicknamed Esperance, its surface etched with delicate, thread-like patterns resembling tiny filaments or worms frozen in stone. To some researchers, these sinuous markings looked hauntingly familiar, almost identical to the microfossils of ancient microbial colonies found in Earth's oldest rocks. The discovery ignited a firestorm. Had we finally stumbled upon evidence that life once thrived on Mars, preserved in mineralized perfection? Or were we once again falling victim to the seductive trap of seeing what we want to see in the Martian wilderness? The debate hinges on a fundamental challenge of astrobiology, distinguishing biology from geology in an alien environment. On Earth, we know precisely what fossilized microbes look like. Their tendrils branch in predictable ways. Their textures bear the telltale sponginess of organic decay replaced by minerals. But Mars plays by different rules. Without a definitive smoking gun, like DNA remnants or complex organic molecules, scientists must rely on shapes alone, and shapes can deceive. The worms in Esperance, for instance, could easily be mineral dendrites, fern-like crystals formed when manganese-rich water seeped into fractures, depositing metallic veins that branch like tree roots. Similar formations occur in Earth's deserts, where minerals like pyrite or hematite paint deceptive fossils onto rock faces. Yet Esperance isn't the only contender. In 2018, Curiosity drilled into a rock called Mojave and uncovered serpentine filaments far thinner than a human hair, some coiled like microscopic springs. These bore an uncanny resemblance to biomorph structures created when microbes interact with minerals, shaping them into organic-looking forms. The team noted their alignment along fracture lines, hinting at fluid flow that might have carried microbial hitchhikers. Still, skeptics countered that purely chemical processes like crystal self-assembly can produce equally intricate patterns without any biology involved. The plot thickened when researchers revisited older findings from the 1990s, the infamous LH8 4001 meteorite. This Martian fragment, discovered in Antarctica, contained microscopic ovoids that some scientists interpreted as fossilized bacteria. Decades later, the controversy still simmers. High-powered microscopy revealed that some structures did resemble earthly extremophiles, but alternative explanations, like mineral growth during the rock's violent ejection from Mars, remained plausible. What makes this debate so gripping isn't just the science, it's the philosophical rift it exposes. Optimists argue that if life arose independently on two neighboring planets, the universe must be teeming with biology. Pessimists retort that extraordinary claims require extraordinary evidence, and so far, Mars has offered only Rorschach tests in stone. The truth might lie in nuance. Even if these fossils are purely geological, their very existence reveals a planet where water and minerals mingled in ways that could have nurtured life. Perhaps the most telling clue comes from Earth's own extremes. In the hot springs of Yellowstone or the acidic rivers of Spain, microbes sculpt rocks into surreal landscapes that, if fossilized, would look unmistakably biological. Yet in Mars' harsh present, no such living artists exist, only their potential echoes in stone. Until we bring samples home or send microscopes capable of atomic-level imaging, these Martian worms will remain Schrödinger's fossils, both alive and dead in our imaginations. What's clear is that the hunt for Mars fossil ghosts has already reshaped how we explore. Every new rover carries sharper tools, trained to seek not just shapes but the chemical whispers of ancient metabolism. Whether Esperance's filaments are stone or story, they've added a vital chapter to our cosmic detective saga, one where every rock might be a clue, and every clue a mirror of our deepest question: were we ever truly alone? The Curiosity rover was trundling across Gale Crater when its cameras locked onto something unusual, an almost perfectly spherical rock nestled among jagged outcrops like a cannonball forgotten on some ancient battlefield. Dubbed the Mars Cannonball by intrigued scientists, this smooth, rounded stone stood out starkly against the fractured terrain. At first glance, it looked like it had been polished by hands or shaped by tools, but the truth behind its formation reveals just how creatively nature sculpts alien landscapes without any help at all. Similar spheres aren't uncommon on Earth. In places like New Zealand's Moeraki boulders or Texas's Bowling Ball Beach, wave action rolls stones back and forth, grinding them into near-perfect orbs over centuries. On Mars, where liquid water vanished billions of years ago, other forces take the lead. The leading theory, concretion, a slow-motion alchemy where mineral-rich groundwater seeps through porous rock, cementing grains around a central nucleus in concentric layers. Over time, softer outer layers erode away, leaving behind hardened spheres like cosmic jawbreakers. Curiosity's cannonball likely formed this way, its iron-rich composition resisting the wind's sandblasting while the surrounding rock crumbled. But Mars adds its own twists. Unlike Earth's concretions, which often form in sediments once submerged in lakes or oceans, the cannonball sits high on Mount Sharp, a mountain built from compacted dust and ash. This suggests Martian groundwater might have been far more widespread and persistent than we thought. Even stranger, the sphere isn't alone. Nearby, Curiosity spotted smaller, pebble-sized counterparts, hinting at an entire battlefield of cannonballs left behind by evaporating aquifers. Then there's the wild card, impact spherules. When asteroids strike Mars, molten rock sprays into the thin air, cooling into glassy beads that rain back down. Opportunity found fields of these tiny marbles in 2004, nicknaming them blueberries. Could the cannonball be a scaled-up version? Spectral analysis says no. Its mineral makeup matches sedimentary processes, not volcanic fury. Still, the resemblance is uncanny, a reminder that Mars often repurposes earthly geological scripts with alien flair. What makes this lone cannonball so mesmerizing isn't just its shape, but what it represents. A time when Mars gurgled with groundwater, its subsurface bustling with chemical conversations we're only now beginning to decode. Every sphere, whether forged by seeping brine or celestial collisions, is a fossilized droplet in the story of a planet that refused to be simple. And as curiosity rolls onward, who knows what other artillery, natural or otherwise, might emerge from the rust-colored dust. The cracked, bone-dry surface of Mars hides a secret buried in its very bones, the ghostly imprints of rivers that haven't flowed for billions of years. From orbit, these ancient channels sprawl across the planet like scars, some wider than the Mississippi, others twisting in delicate braids that whisper of torrential downpours and vanished deltas. The most haunting of all, Nanjing Valleys, a sinuous canyon stretching over 600 kilometers, its steep walls bearing the unmistakable signature of water's patient, relentless carving. But how could a world now so arid, so frozen, have once pulsed with rivers and lakes, and what happened to them? The clues are etched into the rock. When NASA's Curiosity rover drilled into the bedrock of Gale Crater, it uncovered layers of fine-grained mudstone sediment that on Earth only forms in still, quiet waters. Nearby, rounded pebbles lay scattered like forgotten marbles, their smooth edges forged not by wind but by the rolling tumble of a long-dead stream. Even more telling are the cross-bedding patterns found across Mars' diagonal layers in sandstone that, on our planet, form when flowing water pushes sediment into rippling dunes. These aren't just hints of water, they're snapshots of a world where rain fell, rivers meandered, and lakes lapped against shorelines under a pale pink sky. Yet the real revelation lies in chemistry. In 2020, Perseverance rover's instruments sniffed out organic compounds in Jezero Crater's delta, a fan-shaped relic of where a river once emptied into a lake. On Earth, such deposits teem with fossilized microbes, but Mars' waters didn't just vanish overnight. They slipped away in stages, victims of a planetary tragedy. As the planet's core cooled, its magnetic field weakened, leaving the atmosphere vulnerable to the sun's wrath. Solar winds stripped away the air molecule by molecule, lowering pressure until liquid water could no longer cling to the surface. Some fled into space, some sank into the crust, freezing into subterranean reservoirs that might still lurk beneath the dust. The lingering question isn't just how Mars lost its water, but when, and whether life ever took root in its fleeting oases. The timing is crucial. Evidence suggests Mars was wet intermittently between 4 billion and 3 billion years ago, overlapping with the dawn of life on Earth. If microbes emerged in those Martian streams, they might have retreated underground as the surface dried, clinging to moisture in deep aquifers or salty films between grains of soil. It's a tantalizing parallel to Earth's extremophiles, which thrive in places like Chile's Atacama Desert or beneath Antarctic ice environments nearly as harsh as modern Mars. What makes these riverbeds more than geological curiosities is their promise. Every dried delta, every pebble polished by ancient currents, is a time capsule waiting to be cracked open. When Perseverance collects samples from Jezero's delta, it's gathering pages from a lost chapter in our solar system's story, one that might tell us whether life is a cosmic fluke or an inevitability written into the fabric of wet, rocky worlds. The rivers are gone, but their echoes remain, murmuring a challenge across the ages. If not here, then where? Among the rust-colored plains and jagged cliffs of Mars, hidden in plain sight, lie vast fields of a shimmering substance that shouldn't exist: volcanic glass. Not the delicate, bottle-green glass of Earth's obsidian flows, but something far stranger. These deposits, spotted by orbiters like NASA's Mars Reconnaissance Orbiter, sprawl across regions like Cetes Major and Nili Patera, catching sunlight with an eerie gleam. To the untrained eye, they might look like patches of ice or polished metal, but their true nature is even more intriguing. These glass fields are frozen echoes of the planet's volcanic fury, and they might just hold the key to unlocking one of Mars' deepest secrets. Did life ever take root here? Volcanic glass forms when molten rock cools so rapidly its atoms don't have time to arrange into crystals. leaving behind an amorphous, glossy solid. On Earth, obsidian is the most famous example, razor-sharp and jet black, forged in the heart of erupting volcanoes. But Mars, with its lower gravity and thinner atmosphere, allows lava to behave in ways that would be impossible here. When Martian volcanoes erupted billions of years ago, their lava might have met permafrost or subsurface water, triggering explosive interactions that flung molten rock into the air where it flash-cooled into glass beads. Some scientists compare this process to a cosmic version of tossing water onto hot oil, a violent, splattering reaction that littered the landscape with tiny, glassy shards. What makes this discovery so groundbreaking isn't just the glass itself, it's what the glass preserves. On Earth, volcanic glass acts like a time capsule for microbial life. In places like Iceland or Idaho, researchers have found tiny tunnels etched into obsidian microscopic burrows carved by ancient bacteria as they fed on the glass's mineral-rich surface. These microbes, known as endoliths, leave behind chemical fingerprints and physical traces that can survive for millions of years. If Mars ever hosted life, even in its simplest forms, its volcanic glass could be the perfect place to look for fingerprints. The material's smooth, non-crystalline structure locks away organic compounds, shielding them from radiation and oxidation. It's like nature's own cryostorage, a geological freezer keeping potential biosignatures intact across eons. The most promising sites are regions where glass deposits overlap with other signs of past habitability, ancient lake beds, hydrothermal vents, or areas rich in clays. In Nili, for example, orbital spectrometers have detected glass mixed with minerals like olivine, which on Earth often forms in environments ripe for microbial activity. Even more compelling is the glass's interaction with light. Certain types of microbial life on Earth flourish when exposed to ultraviolet radiation, and Martian glass could amplify this effect. If microbes once colonized these glass fields, future missions with UV scanners might detect their ghostly glow even after billions of years, yet the story doesn't end there. Volcanic glass on Mars might also solve one of the planet's biggest logistical challenges: how to sustain human explorers. When Apollo astronauts landed on the Moon, they discovered glass beads in the soil formed by meteorite impact. These beads, rich in oxygen and hydrogen, could theoretically be broken down to produce water and breathable air. Martian glass, if chemically similar, might offer the same lifeline. Imagine rovers mining glass-rich zones, not just for scientific treasure, but for the raw materials of survival. Of course, skepticism lingers. Glass isn't a smoking gun for life, it's merely a promising hiding place. Some researchers caution that the same processes that make glass a good preservative could also mimic biological signatures abiotically. Radiation, for instance, can alter glass's chemistry in ways that resemble microbial activity. And without a rover on site to drill into these deposits, we're left with orbital data powerful but incomplete. That's why missions like ESA's ExoMars rover, equipped with a drill capable of probing several meters underground, could be game changers. If it lands near a glass field, it might finally answer whether these gleaming plains are Martian curiosities or cosmic libraries, holding volumes of untold history in their fragile, translucent depths. Until then, the glass remains a tantalizing what-if, a reminder that sometimes the most fragile things endure the longest, and the quietest landscapes shout the loudest secrets. Scanning the surface of Mars, you'd expect its craters to look like the Moon's jagged, bowl-shaped scars left by ancient impacts. But scattered across the planet are eerie, ghostly depressions that defy this expectation. These ghost craters are barely visible, their outlines smudged like half-erased pencil sketches. Some appear as faint rings barely rising from the plains, while others are nothing more than circular shadows under the right light. How does a crater, a wound in the planet's crust, just fade away? The answer lies in Mars' restless geological history, where wind, lava, and ice have conspired to rewrite the planet's surface over billions of years. One leading theory points to lava burial. Mars was once a world of fire, its volcanoes spewing enough molten rock to drown entire regions. When these floods encountered craters, they didn't stop, they poured in, filling the bowls like batter in a cosmic muffin tin. As the lava cooled, it hardened into a smooth, flat surface, leaving only the crater's rim poking above the new crust like the lip of a buried bowl. Over time, even these rims eroded, worn down by dust storms or cracked by temperature swings. The result, a crater that's technically still there, but invisible unless you know how to look. NASA Mars Reconnaissance Orbiter has spotted these ghosts using radar, which penetrates the surface to reveal the hidden contours beneath. But lava isn't the only artist at work. In Mars' polar regions, ghost craters take on a different form, ice and sediment fill. Imagine a crater slowly collecting dust over millennia, each storm depositing another layer until the depression is packed like a snow globe left out in the sun. Then, volatile ices like carbon dioxide frost seep into the porous sediment, expanding and contracting with the seasons, further smoothing the crater's edges. Some of these craters even exhibit polygonal terrain, where the ground fractures into geometric patterns as the ice beneath shifts. The effect is surreal, a crater that's more memory than landmark, its presence betrayed only by subtle cracks or circular ridges. Then there's the wild card, wind. Mars' atmosphere may be thin, but its winds are relentless, carrying fine dust that acts like sandpaper on rock. Over eons, these particles can sandblast a crater's rim down to a nub, while simultaneously filling its basin with drifts of sediment. In places like Meridiani Planum, this process has created craters so faint they're only visible at sunset, when low-angle light casts long shadows across their edges. It's a reminder that on Mars, even the most solid features are temporary, slowly dissolving into the planet's ever-shifting canvas. What makes ghost craters more than just geological quirks is what they hide. Some researchers suspect these buried bowls could trap ancient water ice or even remnants of Mars' lost atmosphere, sealed beneath layers of protective sediment. Others wonder if the lava-filled version might preserve microbial fossils, much like Earth's volcanic ash entombs prehistoric life. The more we study these spectral circles, the more they resemble time capsules, each one holding clues to a different chapter in Mars' turbulent history. The lesson of the ghost craters isn't just about erosion or burial. It's about perspective. Mars teaches us that landscapes aren't static. What we see today is just a single frame in a film that's been playing for billions of years, where craters rise and vanish, where rivers give way to deserts, and where even the mightiest mountains are ground to dust. These fading scars are a testament to a planet that's always in motion, even when it appears frozen in time. And somewhere in their buried contours, they might just hold the keys to understanding not just Mars' past but our own planet's future. Deep beneath Mars' frozen South Pole, a discovery sent shockwaves through the scientific community radar signals bouncing back from what appeared to be vast, shimmering lakes of liquid water, hidden under over a kilometer of ice. The initial detection in 2018 by the European Space Agency's Mars Express orbiter revealed a 20-kilometer-wide body, followed by evidence of even more potential reservoirs. This wasn't just ice or permafrost. These reflections matched the signature of liquid water on Earth, buried beneath glaciers like Antarctica's Lake Vostok. The implications were staggering. If Mars harbored liquid water today, even in these sunless depths, it would rewrite our understanding of the planet's potential to host life. But as with all things Martian, the deeper we looked, the murkier the mystery became. The first hurdle, temperature. At Mars' South Pole, surface conditions plunged to -110 degrees Celsius, far colder than anywhere on Earth. For water to stay liquid under such extremes, it would need to be saturated with salts like magnesium and calcium perchlorate, forming a brine so concentrated it could resist freezing. On Earth, similar brines exist in places like Don Juan Pond in Antarctica, where water remains liquid at -50 degrees, but Mars poses an added challenge: pressure. Unlike Earth's thick ice sheets, which insulate subglacial lakes through sheer weight, Mars' ice caps are relatively thin. Some researchers argue the pressure simply isn't enough to keep water liquid, no matter how salty. Then came the curveball. In 2021, a team reprocessing the radar data proposed an alternative. What if the bright reflections weren't liquid at all, but layers of conductive clay or mineral-rich ice? Certain smectite clays, common on Mars, can produce radar echoes eerily similar to liquid water. Others suggested the signals might come from pockets of slushy, semi-frozen brine, a state between solid and liquid that would still hint at dynamic chemistry. The debate grew so heated that NASA Jet Propulsion Laboratory ran lab experiments mimicking Martian conditions, showing that while brines could persist, their stability might depend on geothermal heat seeping up from below, a process we've yet to confirm exists on modern Mars. Yet the most tantalizing question isn't just whether these lakes are real, it's what might live in them. On Earth, subglacial lakes teem with extremophiles, organisms that thrive without sunlight by metabolizing minerals in the water. If Mars' underground reservoirs exist, could they harbor similar life? The analogy isn't perfect. Earth's subglacial ecosystems often rely on oxygen swept in by meltwater, while Mars' brines would likely be anoxic and hyper-salty. But life finds a way. In the Dead Sea or Chile's Atacama Desert, microbes cling to existence in similarly harsh brines. Some even speculate that Martian life, if it exists, might use perchlorates not as a poison but as an energy source, a biochemical trick no Earth organism has mastered. What makes this mystery so compelling is the detective work it demands. Every clue contradicts another. The same radar instrument that spotted the lakes also detected patches where reflections vanished, pockets that might represent shifting or freezing bodies. Meanwhile, NASA Mars Reconnaissance Orbiter found no thermal anomalies at the sites, which we'd expect if liquid water were actively melting the ice above it. It's a cosmic tug-of-war. One study confirms the lakes, another refutes them, and Mars remains stubbornly silent. Perhaps the most profound implication lies beyond biology. If liquid water persists today, it suggests Mars isn't the geologically dead world we once thought. Hidden heat sources, whether residual magma or chemical reactions, could still be churning beneath the surface, reshaping our models of how planets age. Future missions might need to drill through the ice cap, just as we've done in Antarctica, to settle the debate. Until then, these ghostly lakes, real or imagined, remind us that Mars still guards its secrets well, and that the most extraordinary discoveries might not lie on the surface but in the shadows beneath. The Martian landscape isn't just still and silent, it's alive with fleeting spectacles of motion, none more mesmerizing than the towering dust devils that dance across its plains. These whirlwinds, some reaching heights of 8 kilometers taller than Mount Everest, are not just meteorological quirks, they're vital players in the planet's dusty drama. Captured in stunning detail by rovers like Opportunity and Curiosity, these spiraling columns of dust resemble Earth's tornadoes but operate by an entirely different set of rules. While our tornadoes are born from violent thunderstorms, Mars' dust devils are creatures of sunlight and temperature. As the sun heats the surface, pockets of warm air rise rapidly through the colder atmosphere, twisting into vortices by the planet's rotation. Without dense air to slow them down, these whirlwinds can spin at speeds over 100 kilometers per hour. Yet their thin Martian atmosphere means they'd feel like a gentle breeze against a spacesuit. What makes these dust devils more than just a celestial light show is their unexpected utility. For solar-powered rovers like Opportunity, these whirlwinds act as unscheduled cleaning crews. Dust accumulation on solar panels is a death sentence for Martian missions. It blocks sunlight and starves the rovers of power. but when a dust devil passes over, its swirling winds scour the panels clean, sometimes boosting energy output by as much as 50% overnight. Scientists affectionately call these events cleaning events, and they've saved missions from premature endings more than once. In 2009, after months of struggling under a thick layer of dust, Opportunity was miraculously revived when a series of dust devils swept its panels, granting it years of extended exploration. The contrast with Earth's tornadoes is stark. Our twisters are feared for their destructive power, capable of leveling towns in minutes. Mars' dust devils, though colossal, couldn't budge a rover or even topple a carefully placed science instrument. Their atmosphere is too thin to pack real punch. Yet they share one eerie similarity. Both leave behind twisting trails etched into the ground. On Earth, tornado tracks are scars of devastation. On Mars, they're delicate scribbles in the sand, sometimes stretching for kilometers before fading like ghostly signatures. Perhaps the most haunting aspect of these whirlwinds is how they shape Mars itself. By lofting fine dust high into the atmosphere, they contribute to the planet's ever-shifting weather patterns and even its notorious global dust storms. Some researchers speculate that dust devils might be responsible for the mysterious dark streaks observed on dunes' temporary stains where fresh, darker sand is exposed beneath ruddy surface dust. They might even help explain how Mars' surface chemistry stays so dynamic despite the absence of liquid water. Watching footage of these towering spirals from a rover's perspective, one can't help but feel a sense of cosmic irony. Here's a world often dismissed as a dead, static wasteland, yet it thrums with motion whirlwinds pirouetting across plains, dust avalanches tumbling down cliffs, frost creeping and retreating with the seasons. The dust devils are a reminder that Mars isn't just a museum of ancient geology. It's a world still writing its story, one spinning column of dust at a time. And for the robotic explorers we've sent there, these chance encounters with Martian weather aren't just scientific curiosities, they're lifelines, moments where the planet itself seems to reach out and lend a hand. In the shadow of Martian rocks, something peculiar keeps appearing: pale, lumpy protrusions that look unsettlingly like clusters of mushrooms sprouting from the rust-colored soil. When NASA Curiosity rover beamed back images of these formations in 2019, the internet erupted with speculation. Were these proof of fungal life clinging to existence on Mars? The photos showed rounded, almost organic-looking blobs nestled in crevices, some with textured surfaces resembling gills or pores. To the untrained eye, they seem to grow in patches, even appearing to spread between photos taken weeks apart. Conspiracy forums lit up with theories, from ancient fungal networks to evidence of a current biosphere hidden in plain sight. But as always with Mars, reality is far stranger and more revealing than fiction. Scientists were quick to offer a less sensational explanation: iron oxide concretions. These bizarre formations are likely the result of water, or what little remains of it, interacting with Mars' iron-rich soil. Here's how it works. Billions of years ago, when liquid water still flowed across Mars, mineral-laden groundwater percolated through porous rock, depositing layers of iron oxide around nuclei like microscopic seeds. As the planet dried up, wind erosion exposed these hardened nodules, leaving them perched atop softer, weathered rock, the gills and pores some observers fixated on. Simply pits and ridges carved by dust storms over millennia. As for the illusion of growth, it's a trick of shifting shadows and rover movement angles changing as Curiosity rolls forward, making static rocks appear dynamic. Yet the controversy didn't end there. A faction of researchers, led by astrobiologist Dr. Ron Gabriel Joseph, argued that mainstream science was too quick to dismiss the biological angle. They pointed to the formation's striking resemblance to terrestrial extremophiles like the black fungi that colonize Arctic rocks or the iron-oxidizing bacteria thriving in acid-mine drainage on Earth. Some even noted that certain Martian mushrooms appeared in seasonal patterns, darkening and lightening with temperature shifts, behavior that on our planet might suggest metabolic activity. The debate grew heated, with critics countering that Mars' surface is far too hostile for life as we know it, bathed in radiation and devoid of liquid water. Iron oxide, they insisted, doesn't need biology to form bizarre shapes. Chile's Atacama Desert is littered with similar mineral oddities, all shaped by sterile chemistry. What makes this mystery so compelling isn't just the question of life. It's how it forces us to confront the limits of our imagination. We're hardwired to see biology in random patterns, a survival trait that served our ancestors well in spotting predators or food. But Mars constantly challenges that instinct. Those mushrooms might be geological mimics, but they're also a test. Can we resist projecting Earth's rules onto a world that operates on its own terms? The answer might lie in future missions. If we ever find life on Mars, it likely won't look like fungi or anything we recognize. It could be a shadow biosphere built on entirely different chemistry, something we're only beginning to imagine. Until then, those lumpy iron formations remain a masterclass in cosmic ambiguity, reminding us that the universe loves a good riddle. And sometimes the most alien thing about Mars isn't its landscape, it's how relentlessly it defies our expectations. So next time you see a photo of Martian mushrooms, remember, they're not a sign of life as we know it, but they are a sign of something equally profound: the universe's endless creativity in crafting mysteries. And whether solved or unsolved, those mysteries keep us looking, wondering, and exploring. One day in April 2014, NASA Curiosity rover aimed its cameras toward the horizon and captured something that sent conspiracy theorists into overdrive. Nestled among the dull, rust-colored hills of Mars, a tiny, brilliant speck of light glowed like a beacon. The image spread like wildfire, with claims ranging from alien outposts to secret human colonies. NASA official explanation: a cosmic photobomb, likely a sunlight glint off a reflective rock, or even a radiation-induced camera artifact. But as with all Martian mysteries, the truth is more layered than it seems. First, let's break down the most plausible culprit: sunlight reflecting off quartz or metallic veins. Mars' surface is littered with silica-rich rocks and iron nodules, some polished to a shine by relentless dust storms. When sunlight strikes these surfaces at just the right angle, they can flare with startling intensity. Earth's deserts pull the same trick. Think of blinding flashes off car windshields or mica-flecked sandstone. Curiosity's mastcam, designed to mimic human vision, would pick up these glints exactly as our eyes would. Even more telling, the light appeared in only one of the rover's stereo images, vanishing in the other, a hallmark of a localized, transient reflection. Then there's the lens flare theory. Camera optics are notoriously tricky under harsh lighting. When sunlight enters a lens at oblique angles, internal reflections can create ghostly artifacts, something photographers battle daily. On Mars, where the thin atmosphere scatters less light, the sun's glare is even more intense. Curiosity's cameras have filters to minimize this, but no system is perfect. Skeptics counter that the light's pinpoint sharpness doesn't match typical lens flares, which tend to smear or streak. Yet orbital images from the same area show patches of smooth, reflective bedrock, exactly the kind of surface that could throw a deceivingly crisp glint. But here's where it gets intriguing. Some researchers floated a wild card: cosmic rays. High-energy particles from space occasionally slam into camera sensors, creating bright pixels or streaks. Mars, lacking Earth's protective magnetic field, is constantly bombarded by these rays. Most are filtered out by image processing, but a well-timed strike could mimic a distant light source. The kicker: these cosmic false positives often appear in random, isolated frames, just like Curiosity's mysterious speck. What gives this debate legs isn't just the scientific back and forth, it's the psychology behind why we want it to be something more. A lone light on an alien horizon taps into deep-seated narratives. campfires in the wilderness, lighthouses guiding ships, even the primal comfort of knowing we're not alone. Mars, with its silent expanses, amplifies that longing tenfold. Every glint becomes a signal, every shadow a sentinel. The light in the distance endures as a Rorschach test for our cosmic curiosity. It's a reminder that exploration isn't just about what's out there, it's about what we bring with us when we stare into the unknown. And sometimes the most illuminating discoveries aren't the ones we make with cameras, but the ones we uncover in the quiet space between expectation and reality. Look at Mars today, a frozen desert stretching endlessly under a thin, pink sky, and it's almost impossible to picture it as a world once brimming with water. But the clues are there, etched into the planet's skin like the faded lines of an old map. The most compelling evidence lies in the north, where vast, low-lying plains form a basin so massive it could have cradled an ocean larger than Earth's Arctic. This hypothetical body, dubbed Oceanus Borealis, isn't just a scientific hunch, it's a story told by the land itself. Stretching along the edges of this basin are features that look uncannily like ancient shorelines, terraces that rise in steps as if carved by waves, and river deltas that empty into nothingness, their once mighty channels now dry as bone. One of the most striking examples is Arabia Terra, a region scarred by what scientists call thumbprint terrain, a series of concentric ridges resembling bathtub rings left behind by receding water. These formations mirror Earth's own continental shelves where sea levels shifted over millennia. Then there's Deuteronomus Menzi, a fractured landscape of mesas and valleys that could pass for a drowned coastline, complete with what appear to be eroded sea cliffs. Even the elevations align. If you trace the proposed shoreline, it follows a near-constant altitude, just as a real ocean's edge would. It's as if Mars left us a geological autopsy, with every incision pointing to the same conclusion. This was a world that drowned, then dried. But where did all that water go? The leading theory is a planetary tragedy written in 3 acts. Act 1, Mars' molten core cooled, killing its magnetic field. Without this shield, the sun's radiation began stripping away the atmosphere, molecule by molecule. Act 2, as air pressure plummeted, liquid water could no longer cling to the surface. Some escaped into space as vapor, some retreated underground, freezing into vast aquifers or locking itself into minerals like clay. Act 3, what remained of the oceans became ice, surrendering to the eternal cold. Today, we see relics of this collapse, like the North Polar ice cap, a frozen puddle compared to Oceanus Borealis' vanished depths, or the Phlegra Montes, a mountain range littered with glacier-like flows that might be remnants of the ocean's last stand. The smoking gun, though, lies in chemistry. Rovers like Curiosity have found rocks laced with sulfates and salts minerals that on Earth form where water evaporates. In Gale Crater, layers of sediment suggest an ancient lakebed that alternated between wet and dry phases like a heartbeat fading, most damning of all. Isotopes in Mars' atmosphere. Heavy water with extra neutrons is overrepresented compared to Earth, hinting that lighter molecules were ripped away by solar winds, leaving the heavier ones behind. It's as if the planet's very air is a fingerprint and it matches the case for murder. What makes this theory so haunting isn't just the scale of loss, it's the timing. Mars' ocean likely thrived around 4 billion years ago, just as life was stirring on Earth. Had microbes emerged in those Martian waves, they might have clung on as the waters retreated, fleeing underground to reservoirs where heat and chemistry could still sustain them. It's a tantalizing parallel to Earth's extremophiles, which thrive in places like hydrothermal vents or Antarctic brine pools. The difference, Mars' biosphere, if it ever existed, would have been pushed to the brink and possibly beyond. Yet the ocean's ghost lingers. Recent radar data hints at liquid water still trapped beneath the poles, and orbital scans reveal river valleys that once fed the Northern Sea, their dry mouths gaping like unfinished sentences. Every mission adds another piece to the puzzle, painting a portrait of a world that was once as blue as our own, a reminder that planets like lives can change beyond recognition. And somewhere in that lost ocean's echo, we might just find the answer to humanity's oldest question: are we alone, or was Mars once a cradle too? Mars has a habit of photobombing its own science. While rovers and orbiters scour the landscape for groundbreaking discoveries, they keep stumbling upon bizarre cameos, objects that look wildly out of place. There's the infamous Martian spoon, a rock balancing precariously on a thin stem, suspended in midair like it was set there by an invisible waiter. Or the flying saucer Shadow, a perfect disk of darkness stretching across dunes, later revealed to be the rover's own wheel imprint catching the low sun. These bloopers aren't just comic relief, they're masterclasses in how our brains trick us when confronting the unfamiliar, and how science painstakingly sorts signal from noise on another world. Take the spoon. When Curiosities' camera spotted it in 2015, the internet erupted with claims of alien tableware. The reality, a textbook example of differential erosion. The rock was once part of a larger layer, but softer material beneath it weathered away faster, leaving the harder bowl of the spoon clinging to a thinning stem. Earth has its own versions, like Utah's balanced rock or the stone mushrooms of Bulgaria, where wind and water sculpt improbable silhouettes. The difference. On Mars, with no plants or weather to soften the stage, these formations look even more surreal, like props left behind on a minimalist film set. Then there's the flying saucer. When a circular shadow appeared beside Opportunity in 2010, conspiracy forums lit up with UFO fever. The truth was far funnier. The rover had pivoted slightly, and its wheel, etched with zigzag treads, dug into loose sand. At just the right angle, the treads vanished from view, leaving only a smooth, saucer-like curve in the soil. The alien craft was literally a footprint, a reminder that even our own machines can become Rorschach tests when viewed through Martian dust. But the greatest value of these bloopers lies in their humility. Every spoon and saucer forces scientists to double-check, recalibrate, and remind the public Mars doesn't follow Earth's rules. Shadows lengthen strangely in thin air. Rocks fracture in ways that defy intuition. Even color plays tricks. A white balancing of images to approximate Earth-like lighting sometimes makes Martian skies look bluer than they really are, sparking false claims of Earth-like conditions. These moments also reveal how exploration has evolved. Early missions like Viking in the 1970s had to defend against Pareidolia with grainy, low-res images. Today, rovers can circle back for closer looks or snap 3D stereo views to debunk illusions on the spot. Yet the bloopers persist because Mars is a planet of extremes, and extremes breed the unexpected. A jagged rock becomes a dragon's spine. A wind-carved ridge mimics a fossilized spine. The more we see, the more the planet toys with our perceptions. What makes these bloopers more than just cosmic jokes is their lesson in scientific rigor. Behind every viral Martian mystery, there's a team of researchers running spectral analyses, testing erosion models, or reconstructing lighting angles in labs. The process isn't about crushing wonder, it's about refining it. When we learn the spoon is just a rock, we're not losing magic. We're gaining insight into Martian winds, the tensile strength of basalt, and the patience of geological time. So next time you spot a statue, log, or thigh bone in rover photos, remember, Mars is the ultimate improv artist, spinning chaos into stories and science. It's the audience sifting the punchlines from the poetry, one pixel at a time. From the haunting face on Mars to the shimmering glass fields of Nili, from methane spikes that vanish without a trace to the ghostly whispers of ancient shorelines, this crimson world has spent decades rewriting the rules of what we thought possible. We've uncovered pyramids sculpted by wind, followed trails of blueberries that hint at vanished oceans, and stared into skylights leading to subterranean labyrinths. We've watched rocks appear overnight, lights flicker in the distance, and dust devils taller than Everest dance across the plains. Yet for every mystery solved, like the doorway revealed as a mere fracture or the crab monster unmasked as a shadow, Mars tosses two new enigmas in our path. What makes these 25 mysteries so intoxicating isn't just their strangeness, it's how they expose the limits of our imagination. Mars doesn't play by Earth's rules. Its geology conjures illusions that taunt us with false familiarity. Its chemistry brews compounds we're still learning to recognize. Even its silence is a riddle, a planet that once roared with rivers now whispering only in echoes we strain to decipher. Every rover we send, every orbiter we deploy feels like pressing a key in a cosmic lock, but the door hasn't budged yet, and that's the thrill. Mars isn't just a destination, it's a conversation. A dialogue between what we expect and what we find, between the stories we project and the truths we uncover. It's a reminder that exploration isn't about checking boxes, it's about learning how to ask better questions. Because the real treasure isn't in solving Mars mysteries, it's in discovering how much we still don't know. So tell us, which of these 25 enigmas grabbed you? Was it the liquid lakes hiding under the ice, or the Martian mushrooms that turned out to be iron's masterpiece? The pyramids that dared us to imagine lost civilizations, or the methane that flickers like a candle in the dark? Drop your favorite in the comments. We're obsessed with these debates. And if you're hungry for more cosmic puzzles, hit subscribe. The universe is overflowing with them, and we're just getting started, because Mars, it's only the beginning. The next mystery is already out there waiting.